So here the next part of the discussion is atoms and molecules, that is third unit. In this, if you go for introduction, in the introduction we take different examples like that is sugar, minerals, sugar minerals, then copper, wood, then plastic, metals like you can take copper metal, sodium, then nickel, magnesium, then you can take that is coal, carbon, graphite, diamond, silica, etc. So all this, what you are finding is these are all different substances. These are all different substances which are a part of matter. Substances which are part of matter. You know very well that matter is nothing but it is simply a collection of particles. Actually we call matter as simply collection of particles. We call them as collection of particles. One is collection of particles, and this matter is in turn made up of atoms and molecules. If you go for matter, this matter is neither created nor destroyed. Matter neither it is created nor it is destroyed, but at the same time it can be transformed from one form to another. These are some of the characteristic features of that is matter. At the same time, if you take atoms, if you take an atom, how can you define an atom? An atom is nothing but it's a part of matter. Atom is the smallest particle, so atom is nothing but a component of matter. It is the smallest particle. It is the smallest particle of matter which cannot be further subdivisible. Cannot be further subdivisible. And but can take part in a chemical reaction. But can take part in chemical reaction. Which can take part in a chemical reaction. This is nothing but atom. So atom is the smallest particle of matter which cannot be further subdivisible into individual fragments, but at the same time it can take part in a chemical reaction, can be called as matter. Then after understanding matter, if you go for molecule, what do you mean by molecule? Molecules also are the substances which are a part of matter which can have independent existence. It is the smallest particle, that is, I can simply say particles of matter which can have independent existence. And you know very well that if the molecules are a part of matter, always molecules are formed because of when atoms combine. When two atoms combine, atom plus atom, when two atoms combine, we always get a molecule. you always get a molecule. And again here if you take, that is, you know very well that atoms are always unstable, all atoms are unstable, and all molecules, they are said to be stable. Molecules are stable because when atoms combine, electronic arrangement takes place within the atoms, and because of that the atoms, after formation of molecules, once a molecule is formed, large amount of energy is released. When energy is released, the energy is lowered. When energy is lowered, then the molecule is automatically, it is going to become stable. But if you take atoms, they are unstable, so electronic rearrangements do not take place in atoms. They have large amount of energy, and that is why we can say that atoms are unstable. But one thing what we have to understand is, always atoms and molecules are a part of matter, and different atoms and different molecules will possess, if the different atoms and different molecules, they always possess different properties. So I can add that here, if you take a part of matter, different atoms and molecules possess, different atoms have different properties, different physical and chemical properties. Different physical and chemical properties. So here the next part of the discussion, based on atoms are the smallest particles. Atoms are made up of smallest particles. Based on their combination, when the atoms combine in the various combination, here we have to study something about laws of chemical combination. If you go for laws of chemical combination, here first one is law of conservation of mass. Law of conservation of mass. Law of constant proportion. And also law of multiple proportion. Law of multiple proportion. So go for law of conservation of mass. If you go for the law of conservation of mass, the first one here, if you go for law of conservation of mass, if you take, it was given by Lavoisier, proposed by Lavoisier or explained by Lavoisier. It says that, what is the principle involved here? We can say that matter is neither created nor destroyed, and the total mass of the substance is conserved. When it is being transformed from one form to another form, the total mass of the substance is always that is conserved. Conserved means remains constant. So what is happening here is, the molecules are the substances which chemically react. Substances which chemically react. Substances which chemically react are called reactants. Reactants. Substances which chemically react are called reactants, and the new substances formed after the chemical reaction, are called products. So what we are noticing here is, suppose if I am taking one example, take one illustration. So if I am taking one example, you take decomposition of limestone. If we take decomposition of limestone, here what we are noticing is, you take calcium, limestone is nothing but calcium carbonate. Calcium carbonate is a solid, so upon heating, you heat it, you get calcium oxide solid plus carbon dioxide gas. Calcium carbonate solid, upon heating it gives calcium oxide solid and carbon dioxide gas. This calcium oxide is also called quicklime. So you calculate the total mass of calcium carbonate. If you calculate the total mass of calcium carbonate, suppose if I am taking, say, that is rough calculation, if you make the total molecular mass. So the molecular mass, what I can do here is, I will put it like this: molecular mass of calcium carbonate is, that is, calcium atomic weight is 40, atomic weight of calcium is 40, atomic weight of carbon is 12, and there are 3 oxygens, 16 3s are 48. So total it is going to become 100 grams. Molecular mass is 100 grams or 100 units, whatever. If you go for calcium, calcium atomic mass is 40 and sulfur is oxygen 60, so therefore it is going to become 56 grams. Carbon dioxide, carbon atomic weight of carbon is 12, and each oxygen atomic weight is 16, 16 to 32. So therefore 12 plus 32, it is going to become 44 grams. So this, the total mass of the reactants must be equal to the total mass of the products. Reactants total mass is 100 grams, and in the products the total mass is 56 plus 44 is again 100 grams. So reactants mass is 100 grams and the product mass is also 100 grams. So therefore the total mass of the reactants and products have been converted, and this here 100 grams is again the total mass of the product. So in this way we can conserve the mass of the reactant as well as mass of the product, and it is able to satisfy the condition of law of conservation of mass.